Kia ora koutou katoa, it's Mrs. Goodson here, and this video is video 9 for Chemistry 2.4 NCA, Bonding and Structure. This video is about molecular shapes. Now you need to know about molecules and Lewis diagrams and covalent bonds and what molecules are before you watch this video. So if you haven't had a chance, go back and at least look at molecules and Lewis diagrams. So this follows on, and it's about justifying the shape, the bond angle, and it's based on VSEPR, which is repulsion theory. So we learnt that electron pairs can be shared between non-metal atoms, and that molecules and ions possess two types of electron pairs. So these bonding pairs are two shared electrons in a covalent bond. Lone pairs are two electrons in a pair not involved in bonding, and sometimes we call them non-bonding pairs. So these electron pairs, because they're all negative charge, they will repel each other as far as possible. And the shape of any molecule or ion, but we're going to focus on molecules, is a consequence of these electron pairs repelling each other as far as possible. Lone pairs, the ones that aren't involved in bonding, they are a little bit closer to the atom, and so that they provide more repulsion. So the greatest repulsion is between two lone pairs, so they're going to have a biggest distance between each other. So the main thing we need to remember at level 2 NCA is that the electron pairs repel each other. They want to get away from each other as much as possible in 3D space. So molecule shapes is all about 3D space. The first step is that you need the Lewis diagram. Now, the Lewis diagrams can be misleading because the bond angles aren't necessarily correct. All the Lewis diagram is showing is the bonding pairs, and so it's kind of flat. And so the Lewis diagram can be misleading. So you've got to very carefully follow the steps to work out the shape. So these are the steps. So this is step 1, is to look at the Lewis diagram and count the areas or the regions of electron density around the central atom. So you have to work out which is the central atom. So assuming you've already looked at the video about Lewis diagrams, you know how to do Lewis diagrams. For example, there might be two regions. In this example, in carbon dioxide, carbon is a central atom, and there's 1, 2 areas of electron density. Now, notice that the double bonds are just one area. They just count as one around. So there's 2 areas around the carbon dioxide. This is an example of, this one is boron trifluoride, and there are 3 regions around the central boron atom. 1, 2, 3. Okay, so that's got 3 regions or areas of electron density around the central atom. So those, and they're all bonding. Okay, like carbon, they're all bonding. There's no lone pairs on the boron. This example here has got 4, 1, 2, 3 bonding, and then this lone pair would be 4. So we count this as 4 areas or 4 regions of electron density, 4 electron clouds around the central phosphorus atom. This example, carbon tetrachlorides, tetra means 4 chlorides around, so the chlorides have all got lone pairs on it, but carbon is the central atom. There's 1, 2, 3, 4 areas of electron density, and they are all bonding. Around water, there is 1 bonding there, 2, 3, 4. So water has 4 areas of electron density, 2 bonding, and 2 lone pairs, 1, 2, or 2 non-bonding. Okay, so the first step is to count the number of regions of electron density around the central atom. We need the Lewis diagram for that. Then we use that to determine the parent or the base shape. So if there's 2 regions, then the shape's going to be linear. And this is an example. So there's 180 degrees between, this is the central atom. If there's 3 regions, it's going to be trigonal planar, and 1, 2, 3, and a bond angle of 120. Okay, so it sits quite flat. That's why we say it's planar. 120 degrees bond angle. And then 4 regions is going to be tetrahedral. 1, 2, 3, 4. And remember, we played with the Molly mods and we saw that in 3D space, these 4 areas or regions around the central atom are trying to get away from each other as far as possible. So the angle is 109 or 109.5, you might see the bond angle. Okay, so they're all 109 between each one. Okay. And we're going to come back to this is drawn in 3D way of drawing it. So 2 flat in the plane. The dashes mean it's going out from behind the flat plane, and the wedge means it's coming out towards us. So we need to remember the angles and the names. So linear for 2 regions, 180 degrees. 3 regions, trigonal, planar, 120 degrees. 4 regions, tetrahedral, bond angle, 109. Okay, so we've got our base shape. So then we need to look at how many of these regions are bonding and how many are non-bonding. And just remember that double and triple bonds count as one area or one region. Okay. I didn't mean to cross that out. So let's look at some examples because it's easier to explain with examples. So look at the water molecule. We look at the Lewis diagram here. This is the Lewis diagram. There's 1, 2, 3, 4 areas of electron density around the central atom, 2 bonding and 2 lone pairs. Okay, so the parent shape is tetrahedral, so the bond angle is going to be 109 degrees, but so the bond angle between here is 109 approximately. The final shape, though, the lone pairs are down here. The final shape is this V shape. So you can call it V or could angular or bent. I remember V shape. I think that's the one I remember the best. But you can, so if it's got 4 areas and 2 bonding and 2 non-bonding, then it's going to be a bent shape. Okay. So here is an example of a linear molecule. So we've got carbon dioxide. It's got 2 areas, 1, 2 areas. So it's got a base shape of linear with a bond angle of 180 degrees. It's got 2 bonding regions and no non-bonding regions. So its final shape is linear. This is an example of trigonal planar. So it's got 3 regions, angle of 120. It's got no or 0 non-bonding regions. So the final shape is trigonal planar. Trigonal pyramid. So this is when there are 4 regions, 3 bonding, 1, 2, 3, 1, 2, 3, and this one is 1 lone pair. So this is ammonia. So it's actually got 4 areas, but only 3 of them are bonding. So it looks like a little pyramid, but the bond angle is 109 because it's got a base shape of tetrahedral. So the bond angle is 109 for trigonal pyramids. And you can see that I've this picture here is the 3D notation or the 3D shape. So we've got nitrogen, we've got the lone pair, we've got this one is flat, we've got one towards us and one behind us, and that gives us the 3D shape. So these are all the shapes you need to know for level 2 chemistry. So you've got linear, we've got trigonal planar. If one of the ones on the 3 is non-bonding, then you get a V shape. Then you've got 4 bonding, which is tetrahedral. You've got 3 bonding, 1 non-bonding trigonal pyramid, like our ammonia. And like our water, we've got the V-shaped, where you've got 2 bonding and 2 non-bonding. So here is what we call a ball and stick model, where we can see the shapes, and we can see how they get their names. And here is a list. So we look at the areas. So we've got 2 is always going to be linear. 3 is either going to be trigonal planar or bent. 4 is going to be tetrahedral. And if it's got 1 lone pair, it's going to be trigonal pyramidal. And if it's got 2 lone pairs, it's going to be bent or V-shaped. So you need to remember the names, how to work out which ones they are, and the angles. Just to review the 3D shapes. So when you're drawing a tetrahedral shape, you've got two in the plane, one that is dashed behind and one that is a wedge which is coming out in front of you. The wedge means it's coming in front of the paper. The dashes mean it's going behind the paper. So this is a template which I recommend that you use for exam answers. So in each, and then you put the name of the molecule, there are either 2, 3, or 4 regions of electron density around the central, whatever the atom is. These repel each other as much as possible in a base arrangement. So you'd say either linear, trigonal, planar, or tetrahedral base arrangement, resulting in, and then you name the bond angle for that base arrangement. Then you say how many of the regions are bonding and how many are non-bonding, and then you give the final shape. So please learn this template and practice using it. Okay? So this video has been about identifying a shape for a given Lewis diagram, including the bond angles, justifying that molecular shape depending on the repulsion between the regions of electron density around the central atom, explaining how the bond angles arise, and using that repulsion theory to explain the shape from the number of bonding and non-bonding regions of charge around the central atom.